In this video, and in a second video, part 2 to follow, I'll be demonstrating a lesser-known algorithm for detached coefficient general polynomial division. It is not synthetic division. The divisor polynomial in this algorithm is not limited to being a linear polynomial. In fact, as I was showing in the second example, it's not even an essential limitation if the dividend and or the divisor polynomial's leading coefficients are not monic, not that is equal to unity. I believe that this multiplicative additive algorithm for polynomial division is at least, or even perhaps more so, efficient and easier to use than the divisive subtractive algorithm commonly taught in schools. I assume that you'll reach your own assessment, and I will also include links, references at the end of the second video so you can investigate it further. In any case, I hope you find it interesting and informative, and I hope you enjoy the videos. Hello, this is going to be a demonstration of detached coefficient general polynomial division. With problem 1, I'm going to divide f1, polynomial f1, by polynomial f2. That is, let's get the pen going, f1 divided by f2. And to accomplish this with detached coefficient general polynomial division, I'm going to set up a table first. First, I'm going to write down the coefficients of the dividend polynomial across left to right, unchanged. So we're going to start off 1x cubed minus 13x squared and 59x and negative 87. Then I'm going to draw a vertical line a little bit in front of the leading coefficient to the end of that one, and to whatever. We're going to draw a perpendicular line to that, like this. And then we're going to draw another line perpendicular to that one again and parallel to the first line, like so. Then one thing I'm going to do is I'm going to figure out, first of all, that let's see, the quotient here will be the leading coefficient of the dividend minus the leading coefficient of the, not the coefficient, leading power of the first term in the dividend minus the power of the leading term in the divisor. 3 minus 2 is 1, so we'll have a linear polynomial. Therefore, we'll have two terms, a linear polynomial and a constant, a linear term and a constant term in the quotient. And so the rest of it will be remainder. So I'm going to put down a dashed line here to separate the remainder portion from the quotient. Then what I'm going to do is I'm going to write down the coefficients of the dividend in reverse order, negated. So we start off with the constant term negated, which is 14, and then the linear term negated, which is 5. And then also in this bottom box here on the left bottom, I'm going to write the leading term, the coefficient of the leading term of the divisor with sign unchanged. So this is just 1. Then what we do is we're going to take down this one here for the leading term of the dividend, and we're just going to copy it directly down here, 1. Then what we're going to do is we're going to go 5 times 1. I'm going to put that here as 5. So there's a diagonal going up from the 1 here, okay? And wherever it intersects the horizontal from, if you will, horizontal that you can draw across the right of the terms of the divisor, we have a multiplication. And then we put that multiplication where the intersection of the two, the diagonal and the horizontal, occur. So it's 1 times 5 is 5, and 1 times 14 is 14. Now, the whatever in this column, the second column over now, can now be summed up. And in this case, unlike with detached coefficient multiplication, we do include in the sum the terms above the first horizontal line. In this case, it's going to be negative 13 and 5. Negative 13 and 5 will be negative 8. And then, now that we've completed that, now we're going to perform more multiplications. We're going to take a diagonal up to the right from 8, and where it intersects the horizontal with the terms of the divisor, we're going to have a multiplication. So this 5 times negative 8 is negative 40, and then 8 times negative 14 is negative 80, and negative 32, so that's negative 112, right? And that goes right up here at the intersection of that diagonal and whatever. Now, the way you know you're done is that when you reach the upper right-hand box here on the diagonal from, say, one of the terms down below and the intersection with it with the horizontal from one of the terms of the divisor, and when you reach the upper right-hand corner here, where the negative 112 is here, you know you're done. Okay, you're done at least in forming the partial products of the polynomial division. Now what we have to do is just finish up the sums. And let's see, 59, 14, and negative 40 will be 33. Okay. And then negative 87 and negative 112 is negative 199. Okay. Now, this means, of course, that what this all is interpreted as is, we know, of course, because it's 3 minus 2, that it's a linear polynomial. It's going to be the quotient. So the quotient is x minus 8 plus remainder of 33x minus 199. You can also put that over the whatever, but that's one legitimate form. So, you know, this is the quotient here. We'll call it Q, and this is the remainder R. And again, you can put the remainder in a different form. Now, one way we can check that is just to do a simple multiplication. So we can multiply the divisor, 1, negative 5, negative 14, times the quotient, 1, negative 8. Okay, that's how we start off our check anyway. Roughly straight line. 1 times 1 is 1. 1 times negative 8 is negative 8, of course. And negative 5 times 1 is negative 5. Negative 5 times negative 8 would be positive 40. Okay. Negative 14 times 1 would be negative 14. And negative 14 times 8 is 80, and 32, that's 112. Then another vertical line, horizontal line. And we just sum up our columns. 1, negative 13, 40, and negative 14 is 26, and then we just bring down the 112. Now, we're not done yet because we have to add this remainder, 33x minus 99. So what we do is, where is our pen? Okay, right here. We put 33 and negative 199. And this is not going to be a multiplication, but this is just going to be a simple addition. So we bring down the 1, the negative 13, the 26, and the 33 is 59. And then negative 199 and 112 will be negative 87. So as you can see, that is, of course, x cubed minus 13x squared plus 59x minus 87. So this, in fact, checks.